The specific gravity and absorption test of aggregates is done to determine, as the name states, the specific gravity of the aggregate, but also to determine the purity of the aggregate material. That is, at times with your stone dust, there are some other particles which are included, and this is a rough way to see how pure your aggregate is. But more importantly, it is done to determine the specific gravity and indirectly determine the number of voids which will be present in a given volume of space when aggregate is placed in them. So as I said, that the purpose of this test is to determine the purity of the material, because at times with your stone particles there other material also comes along with the aggregate. So to check the purity of your material, we do specific gravity. Secondly, your specific gravity values which will be determining are used in the mixed design of your pavement. The water absorption is also determined as a measure of the void percentage, whereas the again, if we have to see the quality of your aggregate, this is another check which we use to determine whether your aggregate source is the same or not, because if usually that aggregate is used in Islamabad is from the Margala hills. So the specific gravity of your source, that is from which hill you acquire the aggregate, will remain the same, and that is a way of determining another way of determining the source of your aggregate, that is from where have you acquired the aggregate. So we all know what specific gravity is. We've been reading about it since our 10th grades, and specific gravity, but once again we'll go through it. That specific gravity is the ratio of your the mass of your substance divided by the volume it occupies. But I'll be going into the mass and volume explanation. But when we perform the test, what we essentially do is we keep the volume constant and we compare the masses. How? We'll go into it in detail once the equipment demonstration is also being explained. So specific gravity, we all know that it is the comparison of your mass and the volume it occupies. However, when it comes to aggregates, there are certain voids which are developed during the placement in a specific volume. Now there are voids which are caused by the interlocking of the aggregate, as shown as being pointed by the pointer on your screen, and there are voids within the aggregate particle itself, like these ones or these ones. So when you are there are three types of specific gravities which we will be discussing: the apparent specific gravity, bulk specific gravity, and surface dry specific gravity. So in apparent specific gravity, what we do is we take the dry weight of the aggregate along with the voids as the volume of the aggregate without the voids, that is these permeable and now the voids within the aggregate could be filled with water, or they could not be. They could be permeable or impermeable. So considering the impermeable and permeable, not considering these voids, the volume of the aggregate when not considering these voids is net volume, and that is how we calculate apparent specific gravity. For bulk specific gravity, we consider the voids within the aggregate itself as well, whereas in saturated surface dry, we do consider saturated surface dry specific gravity, we do consider the voids within the aggregate, but we take the surface dry weight and not the dry weight of the aggregate. More on this when we'll be discussing the experimental procedure. Right now, just keep in mind the dry weight and the saturated surface dry weight. So as I've already told you, the apparent specific gravity is when we take the net volume with we take the dry mass and we divide it by the net volume, and we do not take the impermeable voids. We do not consider the impermeable voids when it comes to the evaluation of the volume of the aggregates. In bulk specific gravity, we do consider the permeable voids, that is the voids within the aggregate itself, and that is along with the voids that the aggregate interlocking cause, and that is why it is called the bulk volume, while the mass is the same, that is the dry weight of the aggregate. Whereas in saturated surface dry, the bulk volume is used, but saturated surface dry weight is considered for weight. Water absorption is another test which is done to determine the void percentage in your aggregate, or to see how much water can your aggregate absorb. You place the sample, you first take the oven dried weight, and then you place the sample for 24 hours in water, after which you take the weight again. So the difference of these two and its percentage is the water absorption percentage. So for performing this test, we will be using the buoyancy balance apparatus. In the buoyancy balance apparatus, it's essentially a weighing balance, but it has a sieve, a wired mesh connected to the bottom of it for taking submerged weights. We will be taking 3 weights of aggregates: the dry weight, the submerged weight, that is when the aggregate is dipped in water, and the third weight is the saturated surface dry weight, where we take out the aggregate which was submerged in water, we take it out and we dry it with a towel, and just dab it slightly so that the surface is dry but the voids within the aggregate are filled. That is the saturated surface dry weight, and then using these 3 weights we calculate the specific gravity, which I'll tell you about once the equipment demonstration or the lab demonstration is done with. So